But I think what's more interesting is, first of all, you have to design the next generation network with the concept in mind that that platform is going to last for 10 years, or roughly 10 years. So when you start thinking about the designs and the features and the use cases, you have to kind of be a little bit more bold in terms of what kind of technologies and features you want to add to the system, because it's really hard to predict what is going to really drive the use and dominate. And you want to make sure that the platform is flexible enough to allow innovation. That was another topic that we discussed early in the morning. So I don't want to spend too much time on this slide, but you just think about the transitions, these transitions when they happened, and what was top of mind at the time 2G technology was being developed, or top of mind at the time 2G technology was developed. And then think about what happened subsequently during that period when the technology was being used. You realize that the initial intention for the technology was actually, people tend to underestimate the uses and the innovation that is going to come along, right? So just two quick examples I will give is that when we had a transition from 1G to 2G, people want to go to digital, higher voice quality, a little bit of capacity, but the expectation that back then, no one could actually envision that the adoption of mobile technology was going to be so huge, right? The adoption went far beyond any expectations, and which drove actually the need for a lot more capacity than was anticipated. And good that some of the technologies were actually designed to accommodate a lot of capacity. Similarly, mobile broadband, when we start discussing introducing data, mobile access to phones, and a lot of people just believe that 64 kilobits was plenty, that no one would ever use more than 64 kilobits per second in a phone. And many of you in the audience may have heard that at that time. And nevertheless, we designed the thing for megabits per second, and it turns out that this was the right choice. So my point here is that we have to look beyond what the current needs are, and you have to really kind of design a platform that is flexible enough to accommodate a wide range of services. And we talk a lot about Internet of Things, and also how we're going to bring in new types of devices, how the world is going to get connected around us. And I think you have to then design a network really that will enable this massive number of things, but things that range not only the light bulb or the thermostat, but also a lot of things are going to be in the time frame of 2020, 2030. What we're seeing in other areas, in other industries, is a lot of things becoming, a lot of technologies becoming more practical. Autonomous vehicles, robots, drones. We expect all sorts of things to be connected and intelligent. And the expectation from the user, as when we look at from a user-centric perspective, we not only have our phones, but now we have everything connected. And the expectation is everything is going to get smart and connected. So the interactions that users are going to have with things that are going to be surround the user is there is some level of expectation in terms of immediacy, in terms of response times, connectivity, access to information, and so on. So I think the 5G is going to take in that user-centric view. So traditionally the Gs and the cellular technology have taken the network-centric view, where you design everything based on a network, and then we say, well, I have some devices that are attached to my network. Now we have to take a different view. We're going to think about a user is going to be surrounded by so many connected devices and so many smart devices that you actually need to design things that are going to be more efficient and optimal for that kind of situation. So the key, from my perspective, is that the network needs to be scalable, to connect and adaptable, to connect everything. So that should be the goal of 5G. And, and this kind of a unified platform should look at not just the traditional dimensions of higher capacity, lower latency, higher data rates, trying to improve cost metrics, and so on, and power consumption, but also look at additional dimensions that are related to reliability and scalability and security. We have speakers this morning talking about security, and as you move towards more of a connected world where we have so many devices and they are going to be connected, security is going to be key. That we'll have to look at it very seriously, how to make sure that the systems are in place to enable secure transactions. And also look at the business dimensions. We see a transformation. I mean, I mentioned that early in the morning. So traditionally, the networks are designed with the access being mined, the subscription and the access to that network being the key driver from a business perspective. I think we need to also look at the transformations that are happening in the industry, how the networks are being deployed, how allowing flexibility to deployment models that will reduce the overall cost of network deployment, which is going to be fundamental going forward. Sharing models, take this to the next level when we think about spectrum and thinking about access networks and core networks and different types of models. Ideally, those kind of concepts would be built into the 5G network design to allow this kind of a flexibility and to enable new business models to actually emerge out of the system. So here I'm just going to illustrate some of the technology components that are being researched and some of the areas that are going to be important. On the side of RF and antenna, a lot of talks about millimeter wave bands, and that's very important because that's how we're going to get enhance the mobile the broadband access with higher capacity, higher data rates. We need to have access to more spectrum, and we have to go to higher frequency bands for that. And there are a lot of good bands that can be used, above 6 gigahertz. There's 15 gigahertz, there's 28, there's 60 gigahertz already being used for unlicensed spectrum, and there is a wide variety of bands. The issue there is to really try to harmonize across the globe so we get the benefits of the scale and benefits of the worldwide adoption. But for that, we need to also look at new designs and introduce massive MIMO, new physical and MAC layer designs. They're going to be integrated to support not only the higher frequency bands, the millimeter wave that has special requirements from a MAC physical layer perspective, but also the associated 6 gigahertz, sub-6 gigahertz air interfaces that are going to be needed to support the higher frequency bands. Just because the high frequency bands, we're not going to have the same kind of coverage and reliability that the lower frequency bands provide, and you have to actually have both working in a very coordinated way. Let's put it this way. So from a radio processing perspective, you see enhancements in terms of allowing more flexible bandwidth allocation, ranging from very narrow band allocations to wide band allocations. And that's going to be important because a lot of these things that are going to get connected around us will have very wide range of requirements. Some of them will just need to be very low power and send a few bits and bytes every so often, so it doesn't need to have access to a lot of bandwidth. Others obviously will require lots of bandwidth. And it's very important to design a system that has that kind of flexibility, which unfortunately is not the case today for LTE. We're trying to address that in the next release of LTE, but still, it's important to take this kind of requirements as we start designing the system from the ground up, so that it's easier to get adoption. If you try to introduce some of these requirements later on, it's always more difficult. All right, so just moving on, So overall, what we see is that we have to, introduce these techniques to kind of enable mobile broadband that will enable user experience improvements and those kind of things, as we discussed earlier, and you hear a lot of people talk about the fact that you need lower latency, you need access to a lot of bandwidth. How to do it? You have to aggregate different bands. We see an environment in the future where we're not going to get around it just being used one band. So being able to have this kind of a multi-connectivity and to support the higher bandwidth and the low latency designs that are needed are going to be critical. And what's important then, as I mentioned earlier, is also the MAC layer needs to be redesigned for millimeter wave, but also we need a MAC layer redesigned for sub-6 gigahertz as well to be kind of unified in a way that we can, the control for the access and the resource management of the physical layer be done in a way that will support low overhead, support low power consumption, which is going to be critical for millimeter wave applications. So I think another interesting component that we're looking at when we look at capacity, we have to provide a lot more capacity because we see the exponential growth not reducing in terms of data demand. And then so how to allow more flexible multiplexing mechanisms for the 5G network. And so for instance, how do we introduce fluid duplex operation, particularly when that is combined with multi-hop connectivity. I think that's going to be an integral part of the design, is looking at multi-hop as a way of extending range for certain types of devices and also providing a more integrated network backhaul routing possibility. So for millimeter wave, as I mentioned earlier, we have a lot of spectrum bands that are going to be very critical for next generation. We have certain bands have, gigahertz of bandwidth available. Some of them several hundreds of megahertz available. So just to put in perspective, here in the US, if you account for all the mobile spectrum that is being currently allocated in the US, not necessarily all used, but currently allocated, is a little over 500 megahertz total across all the operators. And now we're talking about just going to one single millimeter wave band and have access to 500 megahertz or more of band. But that's going to be needed. That's awesome, right? But it comes with certain challenges. To make use of the band, obviously, in terms of propagation, we've done a lot of studies, a lot of universities doing studies as well. The propagation is not as bad as you would think, given the bandwidth is so much higher than the current cellular bands. But there are challenges in terms of penetration losses, so it's very difficult to have an outdoor transmitter providing indoor coverage, and vice versa, an indoor transmitter providing outdoor coverage. So those kind of things are very difficult to achieve. And also due to the spatial nature of the channel models, where you have to, it's actually going to an advantage of providing a lot of capacity. You have opportunities to design antenna arrays that would allow, really massive multi-user MIMO and directivity, but it comes with the cost of we have to be able to track those beams very carefully, also add some variability on the channel that would pose challenges to the mobility. As people move around, it's very easy to lose the connectivity through millimeter wave. So that poses a challenge, but the solution is really to have a more robust mobility system that is really integrated with other bands that are more reliable. In particular, as you go down frequency bands like sub-6 or the current cellular bands. So having that kind of integrated design, also looking at how to reduce the power consumption of these millimeter wave systems, because right now it is a system that is power hungry, and you cannot imagine that we'll be able to afford consuming a lot of power, especially in small form factor types of devices. So having that flexibility of being able to use millimeter wave whenever you have enough power, and doing it in a way that complements the sub-6 gigahertz kind of baseline I think is going to be the ultimate design scenario. Then, just to kind of give you a little bit of ideas in terms of trade-offs, when we talk about mission-critical services, a couple of things that we have to look at is how you're going to trade off reliability and latency requirements for the overall network capacity. So if you think about, the mobile broadband capacity in one dimension, and then you have your mission-critical services, depending on how you want to provide latency support. If you were talking about 1 millisecond, you had a trade-off between, how much more capacity allocate to mission-critical versus regular broadband users. But if you're saying now, oh, I want to provide 100 microseconds of latency, then the operating curve is very different, where you start taking away mobile broadband capacity very fast. So it's going to be critical here to have a very flexible design that would match the requirements, whether it's latency or reliability, to the actual requirements for the application, so that you don't take away too much capacity for the rest of the users. I think then having that in mind when you're designing system resource allocation, MAC layer resources, and overall physical layer resources is going to be critical. On the area of IoE or IoT, for those who prefer the acronym, what we see is a trade-off there in terms of link budget, range, and also power, battery life. So that's something that we definitely need to improve on existing systems. And there again, the idea there is that you design a system in a way that is going to be rely on techniques like multi-hop to get the range extension that you would need without sacrificing, in terms of battery consumption and power needs. Also, you have to also look at how to introduce new access schemes that would reduce the overhead in terms of being able to access the network and be able to get resources allocated from the network. So we have to kind of think about how to reduce the signaling, how to reduce the protocol stack for some of these applications, because these kind of devices, many of them, are going to have a very small memory footprint and low processing power capability. So we need to kind of have a system design that will be able to accommodate these kind of requirements. And it's very important, again, like I said earlier, to have those requirements in mind from the beginning. Because if you try to add it later as an afterthought, it becomes much more difficult to do it. And effectively what it does is that it creates a barrier for the adoption, because things are more complicated than it needs to be. So in terms of timeline, we talked a little bit about that in the morning, just to finalize here. I think, first of all, as many other speakers mentioned, 4G will continue to improve. LTE, we have a lot of features that are being discussed right now in 3GPP, and we see that continuing for many releases and many years still. But the activity in 3GPP around 5G is going to start soon. There are some discussions going on, and I think the first key milestone is going to be a workshop that is targeted for end of next year. And after that, the idea that many companies are talking about is that we'll start with what's called in 3GPP a study item. And because this is going to be a completely new system design, it's expected to be a long study item that would last probably about a year and a half or two. And that will transition into a work item phase. And that's when you start looking at the detailed specification and the text will come out of it. So in terms of timeline, we're expecting, it's very hard to say precisely, but we're expecting the initial specs to come out in the beginning of 2019 to mid-2020. We're hoping that we can actually pull it in and have it around beginning of 2019 so that the specs are stable enough that we can start talking about commercial deployments in 2020. Of course, there are other things going on. You probably have heard about 5G initiatives and trials that are going to happen around certain events in Asia in particular. There is the Winter Olympics in Korea, there is the Summer Olympics in Japan, and both countries are kind of looking at trials of 5G as a way to demonstrate new technologies and new elements. We don't believe those will be commercial grade activities. Will probably be like prototypes and concepts that will be, platforms that will be used to demonstrate some of the elements that we discussed. Thank you.